Hello, my name is Teresa O'Dowd, and welcome to my presentation of my mini project for EdTech 651. This presentation covers my research proposal on Study Island's impact on 7th grade mathematics bench scores. A little background on this project. School districts and proponents of personalized learning have invested millions of dollars in promoting personalized learning software as the best way to prepare students for success. While it is clear that educational technology is making personalized learning more feasible in today's classroom, it is not clear that personalized learning software is the best approach to teaching and learning when it comes to student achievement in grade level standards. So in this proposal, we will examine one personalized learning software product, Study Island. And we have narrowed our focus is, does Study Island help 7th grade mathematics students improve the mastery of benchmark standards? Many of the personalized learning programs used in K-12 rely heavily on personalized learning software. That precipitates a need for research. While there have been decades of research exploring instructional practices related to student achievement in the face-to-face classroom, there is little research regarding the use of personalized learning software as it relates to student achievement. Therefore, it is not clear that personalized learning software is the best approach to teaching and learning when it comes to student achievement in grade level standards. In this research method or design, we will include the context of the study, a description of the participants, data collection procedures, and the proposed data analysis method. For the purpose of this presentation, we will also use demo assessment results to run a data analysis using the SPSS Statistical Software. This will be a quasi-experimental design. There is not going to be a random selection of participants. The research will utilize an assessment approach for collecting data, since this design will allow for quick and reliable collection. So in the quantitative study, we will use the pre-test, post-test model. Students in the participating study are traditionally given a benchmark assessment 3 times per school year. These assessments evaluate the students' mastery of learning the standards that are taught in the subject area and grade level. So we will use this assessment in our study. There will be 2 groups with 1 treatment. Participating in the study will be 7th grade students in 2 classrooms. I have chosen students located in a Title I school district in Texas. This will be the first time these students have used Study Island in school. There are approximately 100 7th grade students in this school. The research will focus on teachers and students at this grade level using the personalized learning software Study Island in mathematics. The study will examine 2 groups of students, benchmark test scores, and those test scores will be looked at the beginning of the school year, the middle of the school year, and at the end of the school year after the use of Study Island. Group 1 will be the control group. Students in this group are located in Teacher A's classroom. This group will take the pretest but will not receive the intervention treatment of using Study Island. Group 2 will be the experimental group. Students in Teacher B's class will be assigned to Group 2. This group will also take the pretest, but after taking the pretest, Group 2 will receive the treatment. In other words, Group 2 will use Study Island software after the pretest. As far as collecting data, students in both groups will receive traditional math instruction after the pretest and prior to taking the post-test. This will be a longitudinal study, so we will have a pretest, a post-test mid-year, and a post-test 6 months. In addition, Group 2 will also use Study Island software a minimum of 1 time per week for a minimum of 30 minutes per week after the post-test. During the mid-year benchmark, the scores of the experimental group, Group 2, will be compared to the scores of the control group, Group 1. And this will be repeated after the post-test 6 months. To ensure other researchers can replicate the experiment and validate the results, this will be a longitudinal study, which will include that pretest benchmark given at the beginning of the school year, that mid-year benchmark, and post-test benchmark given at the end of the year. The type of data being collected will come from the same benchmark assessment used by the school in preparation to measure the 7th grade math standards that are assessed on the statewide STAR assessment given in the state of Texas at the end of the 7th grade school year. The study will collect test score data of the 7th grade math students before and after using the Study Island software. Therefore, an Anova test will be used to compare significant differences between the 2 sample groups. This will be a repeated measures Anova since I am testing for changes over time within the same groups regarding the relationship between personalized learning software program, Study Island, and the student's achievement. Using that repeated measures Anova in SPS, I will analyze the data. This analysis considers between subjects factor like the treatment, in other words, students using the Study Island program, and then the within subjects factor, which in this case will be time, the time between the pretest and the post-test. Since we have more than 2 within subject factors, we will have the pretest, post-test, and post-test 6 months variable. So in the analysis, I will use the pretest and post-test 6 months. As I stated earlier, my data analysis will be using SPSS. I will use the repeated measure Anova, and I am going to use demo data to demonstrate results. Obviously, these will not be valid results because this is demo data. And now we're going to switch over to SPS so we can take a look at how that analysis could potentially be completed once all of the data has been collected. So here we are in SPSS, and I have loaded fictitious data into the SPSS editor. And I'm going to use this for my research proposal example. Here you will see I have an independent variable named treatment, and I have 2 levels. There's level 1, and if I scroll down, you can see there's also a 2. And if we were to go look at the value labels, we would see that level 1 is going to represent group 1, which is our control group, and level 2 is going to represent group 2, which is our experimental group, or the group of students that is actually using Study Island. I have a column for ID, and this represents the students that took the test, so I don't have names, instead I'm using IDs. And then we have our levels here. You can see we have a dependent variable pre-test, post-test, and we also have a post-test 6 months. So now we're going to look at the repeated measures ANOVA. So the repeated measures ANOVA is going to take into account between subject factor like treatment, between subject factor and within factor the time, as far as within subjects, in this case time. So the time between the pre-test, the post-test, and the post-test 6 months. So to do that, we're going to go to Analyze, and then we're going to go down to General Linear Model. And then from there, we're going to go over to Repeated Measures. Now, when we do that, we're going to get a dialog box that's going to pop up. And the dialog box will come up and ask us to define the number of levels within our subject factor. So the number of levels in our subject factor is going to be 3 because we're using the pre-test, post-test, and post-test 6 months. And then it's also going to ask us to name our subject factor name. And for that, we're going to put time because we're measuring the results over time. So now that we have the name of our factor name and our levels in, we're going to click Add here. And there we should have time 3. So then we're going to come down and we're going to click on Define. And when we do, we're going to get our repeated measures window pop up. And so at that point, we want to define the within subject variables. So the pre-test is going to be 1. So we're just going to drag and drop it over here on 1. The post-test, which will happen mid-year, will be 2. And the post 6 months will be 3. So we'll put that in there. And we also, of course, want to move our between subject factor, and that's going to be the treatment. So we're going to move that down here to between subject factors. So at this point, before we click OK, we're going to go up here to plots, and that's going to bring up our profile plots. And so at this point, we're going to want to define our horizontal axis, and then if we're going to have any separate lines or separate plots, we'll want to define that. So I'm going to move treatment down to separate lines, and I'm going to move time up to the horizontal axis. And then at that point, I'm going to click Add. I'll go ahead and click Continue. And now I'm going to go under Options. And again, that's going to pop up the Repeated Measures Options window. And then at that point, I'm going to move treatment and time, as well as treatment times time, over to the display means. So I'll do treatment over here for display means, and then I'm also going to put treatment times time over here. At this point, I want to select a couple of things down here for the display. So I'm going to check off Descriptive Statistics, estimates of effect size, and I'm also going to get the homogeneity test. I'll select that as well. So at this point, I'm going to leave my significance set to 0.05, and then I'll go ahead and I will click Continue. And now that we're back here, I will go ahead and click OK to run the Anova. So I'm just going to press OK. When I do that, we will see that the Anova test is run successfully, and now we can take a look at our results. So I'm just going to expand this out to make this just a little bit easier to see the results. Let me see if I can make this a little bit bigger. Okay, so using the repeated measures Anova and SPS, we are doing our analysis. So now let's take a look at our results that are using our pre-test, our post-test, and our post-6 weeks test. So if we take a look at the within subjects factors, we're going to see that we have our pre-test, our post-test, and our post-test 6 months. If we were to come on down to the between subject factors, we're going to see that we have 2 levels of 1 independent variable for the between subject factors. So the number 1 here, of course, represents our group 1, which is our control group, no study island usage. And then our number 2 represents our group 2, which is our experimental group. And of course, that was the students using study island. Now let's go ahead and scroll down just a little bit, and we're going to take a look at our descriptive statistics. So in our descriptive statistics, we can see here is our pre-test, here is our post-test, and our post-test 6 months. If we come over and we take a look at the means, we can see the mean for group 1, the group that did not use study island, for the pre-test was 54.94. When they took the first post-test, that mean had come up to 63.13. And then when they took the post-test 6 months, it had only come up to 64.72. If we take a look at the same information for group 2, that's the group that had the intervention of study island, they started out with a 53.44 mean. After the first post-test, they had a 65.52, and after 6 months of study island usage, their mean had gone up to 75.96. So let's go ahead and go down and look at a couple of other tests, and we're going to go ahead and look at the multivariate test here. So when looking at the multivariate test, if we look at the PLS trace up here, we can see, if we kind of come over here under the significance, we can see that there is a statistical significance for time because we have a 0.00. So there is a statistical significance for time at 0.00, and if we look at time times treatment, so if we come down here and look at time times treatment, and we also look at the same row here, we will see that there is a statistical significance there as well. So we're using that 0.05 is used as a cutoff for significance. So again, if that value, that significance value, that p-value is less than 0.05, we would say there is no significant difference between the means and conclude that a significant difference does not exist. If the p-value is larger, which in our case it is, then we're going to conclude that there is a significant difference. All right, so let's go ahead and move down. And I may not pronounce all of these tests correctly, but we're going to take a look at the Mauchly's test of specificity. If I said that right, probably not. We're going to take a look at that one. So here we, if we take a look at this, and again, we're looking at time, and we're going to go over, we'll go over here, and we will look at the significance here. We notice that we have a statistical significance result. So that means that in this case, it means that we may have violated the assumption of specificity. So specificity is the assumption of a repeated measure Anova. And when you violate it, it usually occurs when there's a variance or occurs the variance calculation may be distorted. That's what the violation means. So basically what that means is when we go on down to look at the test within subject effects, we don't want to actually use the specificity assumption. We're not going to look at that significance. Instead, we're going to, and that's what we're going to look at next, we're going to look at maybe something like the greenhouse geyser, or maybe even this one, I'm not 100% sure how that's pronounced, but I'll say the Waffen-Felt. So we'll take a look at those two instead. So here we have time, and we have our time times treatment. And if we were to look at, for example, the greenhouse geyser, we see there that we actually do have statistical significance showing there. So now let's go ahead and we're going to go down and we're going to skip some of these tests, and we're going to take a look at the Levine's test of equality of area of variance. So looking at this Levine's test of equality of area of variance, if we look at the third variable, so let's just jump right to the post-test 6 months. If we come over and we look at that, we're going to see that we have a statistical significant result here of 0.22. So we would assume that we have violated the assumption of homogeneity. So in that case, for that variance, the Anova uses that assumption of homogeneity of variance to test the variance of equal across groups and samples. So since we have violated that, we're just going to go ahead and move on down to the test between subjects and effects. So here we have the test of between subjects and effects. And let's go ahead and take a look here at the p-value. So we'll come over here and we'll look at the treatment. And we'll see at the p-value here is 0.258. And we know we're thinking in terms of that 0.05 as kind of our cutoff. So when looking at the tests between subject effects, we see the p-value of treatment is 0.258. So in that case, that is not a statistical significance because it is greater than 0.05. So we're not even going to concern ourselves with that. So at that point, let's go ahead and move on down to the profile plots. So if we take a look at the profile plots, here we have the time at the bottom. So this indicates where our pre-test was. This indicates our post-test, and this 3 here indicates our post-test 6 months. And then of course these over here are going to represent our means, our mean scores. So the treatment group, group one, that group, which of course is the group that was our control group, is going to be represented by the blue line, and then our experimental group, or the group that received the treatment of Study Island, is going to be represented by our green line. We can see when we're looking at this that control group 1, which is the blue, their scores did increase from the pre-test score here to the first post-test score, and then to the post-test 6 months. It looks like the increase slowed after the initial post-test to the post-test 6 months. We don't see a very great deal of movement in scores there. If we look at group 2, so represented by the green line here, we can see that the score increase moving from the pre-test to the post-test, and then it continued at pretty much the same angle to the post-test 6 months. So the statistics seem to show a significant improvement in group 2 scores from the pretest to the post-test 6 months. Not only in our plot here, but also, of course, in our mean. In that case, it shows that there was less of a significant improvement in group 1. That's the control group, in their scores from that pre-test to that post-test 6 months. So the data analysis that we have done seems to demonstrate that the group of 7th grade math students using Study Island, which if this is the green here, improve their overall mastery score on the post-test of benchmark standards. And this study supports that there is a correlation between 7th grade mathematics students who use Study Island and their improvement on achievement on benchmark standards. So that concludes my presentation, and I want to thank you for watching.